Listen for Enterprise.
Yeah.
Based in San Francisco, so I bet you're happy about the weather here.
It's awesome.
Yeah. Before that, you were working for VMware, and then several years at Google. And this is actually one of the talks that really popped out when I looked at the schedule, so I'm happy to be here too. The floor is yours.
Cool. Thank you very much for the intro, John. Hello, everybody. So my name is Patrick Chanezon, and I had a pretty long career at many different companies. I'm an ex-Java guy from Sun. My first language on the server side was JavaScript at Netscape many years ago. I find it really cool that it's coming back in fashion right now. In 2005, I joined Google as the first evangelist that they hired when they started doing APIs and developer programs. And I've been lucky there to be able to work on many different projects, from ads to e-commerce, social, HTML5. And the past 2 years, the last 2 years that I spent there were on something that was emerging, something called Google Appengine and what became the Google Cloud Platform. So I spent 2 years there, and after 2 years I got a little bit frustrated because I talked to lots of Java developers and lots of my friends who were working in the enterprise. I told them, hey, this is Appengine, we run Java, there's lots of stuff you can do with this cloud platform, why don't you guys use it in your enterprise projects? And many of them laughed at me and said, hey, sorry, we have lots of sensitive data, we need to keep them in-house. So we like your platform for playing during the weekends and all that, but we won't run our mission-critical enterprise stuff on it. And so that was around like 2011. And actually, it's the time when I came to JFocus. I came here last time in 2011 to present Google Appengine, BigQuery, and the whole Google Cloud Platform. So if you want more details on this one, you can go back to the archives. So that was Google, and after 2 years there, enterprise wasn't taking off. Google Cloud Platform became very successful for social and mobile apps. And at that time, a group of Googlers with whom I had worked before, Derek Collison and Mark Likovsky, had moved to VMware, and they released this new open source platform as a service called Cloud Foundry. And when they did that, I just pinged them and I said, hey, I'm really interested in that. That sounds like a good developer play. You would need developer relations. And so I joined these guys. And I worked with Chris Richardson, who's somewhere in there and gives a talk later. He's over there. To popularize Cloud Foundry, especially in the Spring community. So I'll talk about Cloud Foundry a little bit there. After a year and a half at VMware, VMware decided to do a spin-off of the entity that was building Cloud Foundry, and they called it Pivotal. And I believed their story a little bit less. The one with VMware to me was pretty powerful. I'll tell you later in the talk why. But it became less alluring to me. I thought they have less success than the giants like a Google or Microsoft. And so Microsoft had pinged me for a while, and after like a little bit of discussion, I had a meeting with Satya Nadella, who heads the enterprise team at Microsoft, and then with Scott Guthrie and a bunch of other guys from there, and they were starting a new team in developer relations focused on the enterprise. And so they hired me to manage that team, and I joined them like 8 months ago or something like that. And it's been a pretty exciting ride. And one of the aspects that I want to convey here is that before joining them, I wasn't aware of the amount of interoperability and open source work that Microsoft was doing, and especially about the fact that they're very serious about Java. So I'll tell you a little bit about that. So the goal of this talk is not to just like talk about Azure and pitch like various platforms to you. The goal of this talk, it came to me after discussing with lots of enterprise customers. Many of them were, over the years, between the time when I was at Google in 2008, trying to pitch cloud platforms to enterprise customers, And this year, there's been a sea change, and I've seen enterprises moving from, we'll never put our data in these clouds, to today, how do I build my hybrid cloud? And the goal of this talk is to give you an idea, based on the various platforms that I used or analyzed or worked for, how these guys built it and what kind of principles you guys need to think about when you're building your own hybrid cloud platform, which to me is what seems to be happening a lot in the enterprise right now. But first things first, why am I giving this talk and why are you guys here at this conference at JFocus? I don't know about you, what brought you to do software engineering. During the speakers' dinner yesterday, we had lots of discussion about that, what brought us there initially. And for me, it's really a childhood dreams. When I was a kid, I used to read a lot of science fiction, a lot of Asimov and Arthur C. Clarke. And I was dreaming of the future when I would be old, which is now. I'm 45. And I was 10 when I was reading these books. I thought, okay, when I'm 45, there will be speaking robots, and maybe I'll build machines that are smarter than I am. I don't know what brought you in this business. That's what brought me in there. I have to admit that we have smarter phones today, but I'm very disappointed. Even the fact that we don't have flying cars. But beyond flying cars, even the state of the machines that we're building is very dismal, and I'm very disappointed from when I have this conversation with the 10-year-old kid that I used to be. There's a movement in Silicon Valley that's called the Singularity Movement. That's very fashionable right now. Lots of Google people are in there. And what they're explaining is that they're basically extrapolating what happened with Moore's Law to all the areas of human knowledge. And then they say, oh, if it continues like that in 20 years, our machines will be smarter than us and they won't need us anymore. It makes for great science fiction. So if you like science fiction, I recommend Charlie Strauss. He wrote some great books. Accelerando is a good one. Very good fiction, very good movies, potentially. But personally, and I'm pretty sure you're all software practitioners, I think this is complete bullshit. And the reason for it that I'm sure you're well aware of is while the curve on the left that you see here, which is Moore's Law, which states that the number of transistors we put on chips doubles every 18 months, it held true in the past 40 years, which means that the machines we're using today are 1 to 2 billion times more powerful than the ones from 40 years ago. Even if that's true, the curve on the right is very true as well, which is the productivity, the evolution of software development productivity over the same period of time. What you can see there is that essentially the factor here is not 1.2 billion, it's 3, a factor of 3. So we have better ideas, better machines, better tools and languages, but still developer productivity is the big issue. And the systems that we're building are bigger and bigger, and so we're crumbling under the load of complexity. And to me, cloud platforms and infrastructure are just one way, maybe to get a factor, one more factor of 2 to 4 in the next few years in this fight for getting better productivity for developers. It's not a magic bullet. I don't think it will give us the singularity, but at least it will give us an ability to build these giant complex systems in an easier way. There's another pretty interesting blog post that was done by Herb Sutter. He's a software engineer at Microsoft, and he was talking about the fact that the free lunch we had with Moore's Law over the past few years, about the past 40 years, it's arriving to an end. The size of the transistor that we're putting on chip becomes so small that there are some physical limits to especially how much data you can go in and out of the processors. And so he has a long article about this. The gist of it is that the hope for continuing to get ×2 and ×4 more power into the machines we're using is to use cloud machine, to use horizontal scalability. So there's no escaping the fact that in the big systems that we're going to build in the next few years, we need to use some kind of horizontal scalability. Another aspect that's pretty important to me is that when talking to software engineers who have been in the craft for like more than 20 years, very often you see the discussions are turning around. Yeah, I've seen something like that before. And I'm pretty sure for those of you who are old enough to remember, like the transition that we're seeing right now, you've seen that happening before. And the cycles are a little bit like that. Like in the 60s, everything was centralized on mainframe. There was virtualization at that time already in mainframes. All that stuff has been invented in that period. And then there was the big change in the 80s where with very cheap PCs that could be dropped everywhere in offices, the way we build applications changed from the mainframe way where it was all centralized with a VT100 dumb terminal to a client server where you would put a lot of smarts in the client, and then you had client-server interaction. Usually the server was a SQL, vertically scalable SQL database on the server side. So that was the 80s. In the 90s, and I was at Netscape at that time, and I remember the first web app I built with a JavaScript backend I talked to my friends and I told them, hey, this reminds me a little bit of mainframe programming. Everything happens on the server side. The browser at the time was a little more than a dumb VT100 terminal, but with nice fonts and images, but no smarts on the client side. So the web to me was kind of back to the mainframe era where everything was centralized on the server side. And right now what's happening, I would argue in the past 4 years, is a conjunction of two trends. On the client side you have these mobile operating systems, both Android and iOS and Windows Phone, who become as powerful as the desktops from 20 years ago. If you look at the HTML5 spec, you have everything you need to build rich client applications. So mobile phones are becoming much smarter. HTML5 browsers are becoming much smarter as well. So you have the ability to build very rich front end. And then on the server side, these cloud platforms who let you leverage horizontal scalability without having to build that yourself and treat data and number of users that are one order or two orders of magnitude bigger than what you could handle before. So that change, this kind of architecture change happen every 15 years in our industry, and I've seen this one happening in large consumer companies. So it started happening at companies like Google when Larry and Sergey created Google. Instead of doing like every startups, so they created that in '98, and there were students in Stanford. Instead of doing like all the startups from the dot-com era who would raise $1 million and go give half of it to Sun and half of it to Oracle for vertically scalable infrastructure, they just went to Fry's and it's an electronic shop in Silicon Valley. They bought a bunch of hard drives and standard parts for PCs, and they built the first Google server with that. And what they did is on top of all these standard parts, they built a horizontally scalable distributed system. And then once they created the company, all the systems that Google have built have the same philosophy, which is they start building their own, so Google builds their own hardware, design their own data centers, and then build that distributed computing fabric on top of it to just mask the fact that you're using a big distributed computer. So Google developed some stuff like that, Amazon as well, Yahoo, Facebook, and Twitter. That happened over the past 10 years. data sets were larger and larger, the storage was very big, networks became very fast, and that big move from vertical to horizontal scalability, to me, that's what the cloud is. The cloud is essentially what we call cloud platforms, are a productization of this infrastructure, either by providers like Google, who take their existing platform that they built and expose it to third parties. So Google and Microsoft and Amazon are in that case. Or companies who take either take what they have been building themselves, or read research papers by some of these companies, and then build open source components that allows you to implement that in-house, in open source or in proprietary software. So I love that quote by William Gibson saying, "The future is already here, it's just not evenly distributed." What it means to me when applied to cloud platforms is that these platforms have been used by these large consumer companies for several years already. And now the challenge is how do they get adopted in regular computing. It has started in consumer companies already, and the next challenge is how do they get adopted in the enterprise. So when you look at how Google builds its platform, one of the interesting aspects to look for is reading the research papers. So Google has a whole research papers section on its website, and you can go look at and read the papers where engineers are describing the systems that they're building. And so I remember before joining Google in 2005, I had read the paper about GFS and MapReduce, so the distributed file system, and then MapReduce, which is the model for processing large quantities of data. And it was available online in the papers library, while there was no external implementation of that yet. And what I found really interesting in the past 10 years is that what had happened is these advances that Google made in its own infrastructure, described in public papers, they were usually picked up by other companies and implemented as open source. And so reading these papers kind of gives you an idea of what's coming next in these areas. So for example, the horizontal scalability paper, the MapReduce paper, is from 2004. In the past 2 years, so MapReduce is the base for Hadoop. It's been picked up by people at Yahoo, and they implemented an open source version of that. It's the Apache Hadoop project. Now there are multiple vendors who provide Hadoop, like Cloudera or Hortonworks. Microsoft has one called HD Insight. So that paper is from 10 years ago, and the market is maturing for it right now. So it's really an interesting thing to see that a 10-year-old paper is still pretty or fashionable right now. The NoSQL movement that exploded a few years ago is all based on the Bigtable paper from 2006. So that's Mongo, Cassandra, HBase, React. They're all based on like variation on the ideas in that paper. Real-time analytics in 2010, the Dremel paper. So it's a product that was used internally at Google to be able to query interactively petabytes of data, usually logs data. So all the teams had access to this kind of logs data, and were using that tool on the command line to analyze data in a... So you receive the result of the query in real time. That has been productized by Google as the product called BigQuery. So it's part of the Google Cloud Platform, and you can use it today. And it took a while, but after, so the paper is from 2010. I think Impala, Cloudera Impala, which is an implementation of a similar system, has been implemented only like 1 year and a half ago. Maybe it's 2012. So it took 2 years to have an open source implementation. Now I think Impala is available for everybody, and you can buy it from Cloudera or download the source code to build your own. Now, what I find super interesting is the latest papers that Google has published, the ones in 2012. about a system called Spanner and a database called F1 that they built on top of that. And I don't think there's, maybe Amazon Redshift has some of the same characteristics, but I don't think there are equivalent systems that exist out there. So what Spanner and F1 are is Google took the BigQuery, not the BigQuery, the Bigtable notion, and on top of Bigtable, they added a SQL layer on top of Bigtable and made it distributed across data centers. And they're doing Paxos replication between the various Bigtable cells. And in order to get better performances, they use atomic clocks in the different data centers so that each of them has a pretty precise time for the replication. What they built on top of that, so it's basically a SQL engine that's cross data center that can have petabytes of data and lets you do transactions on top of that. What I find super interesting in reading this paper is that they started all this cycle of everybody trying to move from SQL to NoSQL in 2006 with the Bigtable paper. And then they built that relational database for their own use. So when you read the paper, you understand that F1 has been built for the ads database, which used to be MySQL with a sharded extension. And MySQL was not enough anymore. They tried to move to Bigtable, but they needed the relations and the reports and the transactions. And so they built a distributed relational system. So what I find interesting in this story is that when you read the papers, you kind of have an idea of what's coming down the pipe. And you also have an idea of the fact that the industry we're in is very cyclical. So when you're looking at systems and you want to move, for example, an application from SQL to NoSQL, you should ask yourself the question, is it really what I need? Look at your requirements first. Don't believe the hype. Requirements are what's important at the end of the day. So Google has built all these various services. One of the aspects that's important is the focus on building it once and then enhancing it until they need a new version for it. And having all the teams at Google, when you build a service, you just leverage the existing infrastructure instead of recreating your own. So that avoiding that not invented here syndrome and reusing common infrastructure is, to me, one of the single factors that have Google engineers that makes them so efficient in what they do. Now, one of the things that happened after a few years in 2008, having all this infrastructure, some guys at Google created a platform called Appengine and created that notion of platform as a service. And then later on, it bloomed into what became the Google Cloud Platform. I won't go in the details about that, but basically in the Google Cloud Platform is what Google exposes for third parties to use to build their own applications. And in there, they have so they have Appengine, which is platform as a service. I think it's 4 languages now, Java, Python, PHP, and Go. They have a compute engine, which is virtual machines. So you can really provision Linux virtual machines, and there's tons of flavors of Linux in there, and you can install whatever you want in there. So they have storage. They have SQL. One of the interesting aspects in there that's a pretty good differentiator is on the data side. BigQuery is really an interesting aspect. So I highly recommend you guys to take a look at it. So that's kind of the Google Cloud Platform. Now, on the Microsoft side, I would say the vision of Microsoft is slightly different. Google is building its infrastructure and data centers to serve its own needs for its own workloads, and then exposes part of it as a public cloud for customers. And it worked really well for consumer companies, people building social games or mobile apps. it really didn't take off that much in the enterprise. For enterprise developers, there are lots of data they want to keep within their data center. They want to have some control. And what I've heard consistently that they want to have some hybrid approach. Have some of their application that they host internally, and some others that they host in public clouds, and have common tools to manage all that. So Microsoft has taken this approach.
Should we switch? Okay, I'll take that. Okay. Thanks. Go.
Let's see how that goes. Yeah, so looking.
Yeah, I'm looking at the sound guy.
Yeah, so that works, thanks. All right, so the Microsoft approach is quite different. Microsoft has always been very good at taking innovations that happen elsewhere, packaging, I knew that with this group that would work out pretty well. I mean, I'm coming from Netscape and Sun. I've seen them doing that over and over again, and they're very good at it. Competing with them for like maybe 10 years out of my 20 years career gave me a lot of respect for what these guys have achieved. So Microsoft is very good at like taking innovation and then packaging it up so that it's very usable. And that's something that innovating companies like Netscape and like Sun were much less good at doing, frankly. Where many of the companies where I've worked, and Google was a culprit of that as well, a lot, were like very elitist and saying, oh, you know, there's this pyramid of developers and we're just shooting for like the top, the best ones, those who are creating really completely new stuff. And we won't care about the other guys. They can try to learn if they want, but we won't make our tools easier to use and all that. Microsoft, they're very good at taking something, making it better, and then grinding it, making it better and better and better every year until it becomes better than competitors. I've seen it happening with IE versus Netscape at the time. I've seen it happening during the Java versus .NET wars, and then I see it happening in the cloud right now. When Windows Azure shipped I think it was 2009 or something like that. My colleagues at Google were laughing at it. We were seeing the Microsoft evangelists taking 5 minutes to deploy an application where on our platform it would take like 30 seconds. The thing is they keep at it and enhance it all the time. And right now the Microsoft story is pretty good. There's Azure on one side who matured a lot. So Azure now has a bunch of cloud services, virtual machines, a pretty strong infrastructure as a service story, all driven by APIs. For Java developers like you guys, there's two ways to use Java. There are VMs coming from Oracle with WebLogic and Java and the Oracle database. that you can run, and they're supported by Oracle. So if you're in an enterprise, it's pretty easy to move there. Or there's the Azure open source GDK that runs in pass mode. So you have these two options. But beyond Java, there's you can run Node.js and PHP. There's a pass mode, an IIS mode, things in the middle, lots of automation with PowerShell. So Azure has matured a lot. And there's ways to do site-to-site VPN, to do dedicated connection between your company and Azure, and to manage the networking like really your way. And I'm in lots of conversations with companies right now about doing things like that. But the beauty of the Microsoft approach, and where I think it's pretty powerful and differentiated, is in the fact that it's really a hybrid approach where Microsoft also has the same tools to let you create your private cloud with Windows Server and Hyper-V. And there it's in competition more with companies like VMware, more than Google and Amazon. So it's fighting with VMware in the enterprise inside the firewall to let you manage all your virtualization, all your servers with tools like System Center. And the differentiation with both these competitors is that with something like System Center and the Azure Pack, you can install the equivalent of Azure inside the firewall, and then use System Center to manage resources that are both inside your private cloud and on the public cloud. So that kind of hybrid story is, to me, one of the main differentiator that Microsoft has. So I talked about the Oracle VMs. Just wanted to talk about, so I talked about the Azure Pack and all that, so that's what that looks like. Basically, you have a self-service portal that you can use externally for Azure if you sign up for it, and you can sign up for free to get started. But with the Azure Pack, you can install something internally that will let your developers use the same tools, same APIs, and same UI to just manage your private cloud. So if there are some apps that you want to deploy only internally, you can do it this way. Then it's multi-cloud. So there's this partnership ability where Microsoft has always been strong at creating an ecosystem. And with Amazon, if you run your workloads on Amazon, it's Amazon, you're dealing with Amazon, and they're your provider, and that's it. Google, it's the same thing. It runs in the Google data center. These are proprietary technology that run only in their data center. On the Microsoft side, this Cloud OS vision is that you can build your own cloud within your data center. You can use the Azure cloud from Microsoft, but you can also use our technology from this network of cloud providers. And we know that in the enterprise, people are very sensitive to who they give their data to. Maybe they don't want to give it to Microsoft. Maybe we don't have a data center in your country. We have partners who have data centers in many different countries, or who specialize in different types of workloads that you can use. Then one of the technical things I wanted to talk about, which we'll see. So Google has an equivalent thing, and VMware has an equivalent thing in Cloud Foundry. And to me, that's kind of the new thing that's emerging. That's kind of important to wrap your head around, because whatever cloud you're building, whether it's open source or proprietary, behind it there will be this notion of a fabric. And so it's called the Fabric Controller in Azure. In Cloud Foundry, it's called Cloud Foundry Bosch. It's a set of tools that lets you deploy and manage Cloud Foundry. And essentially what the Fabric Controller is, it's kind of the new operating system. So it gives you, running out of time. So it what replaces the operating system. So instead of managing, we're changing scale. Instead of managing servers, we're managing data centers. The kernel that used to manage your hardware becomes the Fabric Controller, who knows what kind of resources are in the data center and what type of workloads you want to deploy there, and it's the one that's orchestrating this deployment. So maybe I'll skip. So Fabric Controller, this is how it's implemented in Azure. It's a stateful application. It's one of the only ones in Azure. And it's replicated for availability. And so when you're interacting with Azure in the portal, essentially what's happening when you're deploying an app is going to a service called RDFE, where it gets stored, the app gets stored, and then it talks to the Fabric controller who takes care of deploying it to the right instances, depending on what you ask for. Data is another piece of the puzzle for when you're building your cloud. So in terms of data services, what you want to get is services that scale. So right now, Hadoop is kind of the thing that's very fashionable. I think like databases like Impala or services like BigQuery are going to become more and more commonplace. I would say the big Microsoft differentiator here is in usability. For end users, when you're using HD Insight, which is the Hadoop implementation where that's part of Azure and that's self-managed, you can access it from Excel, and there's tons of visualization that are out of the box with it. So you don't need to have developers who write command line and maybe applications for your users. You can give your users access to the HD Insight cluster directly into Excel. So I would say that's our differentiator there. Now let's talk about Amazon. So Amazon is well known. This is kind of an overview of everything that's available in there. I'm pretty sure you've heard about them. Amazon Web Services is the most mature cloud platform out there. I'd say they're the ones with the most distinct type of services that they offer. Everything from infrastructure to networking to analytics, application services. A few remarks about what they've been doing. One notion that they developed that I liked a lot is the notion of the two pizzas team. When you're building your apps, and Chris Richardson actually gave a talk, I highly recommend you to try to find some videos or the slides of his talk about how to decompose your application in that cloud world, essentially decomposing your application in various services. At Amazon, they're building all their apps like that as services, and their criteria is to have teams that can feed on two pizzas that work on one service. That's kind of the unit of communication where the communication doesn't break. If you can share two pizzas together, you can communicate together well enough, and then the communication with other teams happen through interfaces that you define for these services. I think that's a very good approach that should be replicated, especially in the enterprise. And one aspect that comes with it is this DevOps movement that becomes more and more fashionable. That comes from the consumer world as well, where this team that feeds on two pizza, they are building the service, but they're also operating it. So there's no more nuance between dev and ops. Devs throwing code over the wall to ops. It's like the same team who's responsible for monitoring it and running it. I highly advise to read the Dynamo paper. It's very good. So Amazon uses a lot of open source software, but doesn't contribute much. There's been an article about that recently in the reg. One of the things I found interesting is that they have a platform as a service called Elastic Beanstalk. And they have always said, oh, we really don't do platform as a service. But then over the years, they added like .NET, Java, Node.js, PHP. So they have a pretty complete platform as a service support there. What's interesting in their approach with Beanstalk is that they still let you access to the underlying resources. So you can let them manage the platform that runs your code, or you can go in the detail and say, hey, I want a more powerful VM for that Tomcat instance. And for PaaS, usually they have partners. People like Heroku or Cloud Foundry are running on Amazon Web Services. Where I'd say they are weaker is in their hybrid story. So they have pretty good networking construct for creating direct link between your data center and Amazon. But inside the firewall, they don't have that of a good story. Eucalyptus may be a solution for that. The last one I wanted to talk about is Netflix. Netflix is interesting because they're a consumer company. They're building a streaming service. So you would say, what are they doing in the cloud platform business? And what happened is that they realized that they needed a very scalable, huge platform for their streaming application and their streaming service, but that was not a competitive differentiator in what they were doing. So they decided to open source it. And the advantage of that for them is that it's easier to hire, and then they get lots of external developers who are helping them build the platform. And I'm mentioning that because Netflix there's lots of Java there. So it's a very Java-oriented company. Carl Quinn is working there. He gave lots of talk about their infrastructure. I highly advise you to take a look at what these guys are doing. It's super interesting. Their goal is to lower the MTBE, the mean time between ID and making stuff happen. I think that's a very good goal for building your platform. The thing is, it works only on top of Amazon Web Services. Notable in there are a bunch of services that they have created on top of Amazon to just complement it. One of the very interesting aspects to take in Netflix is the Simian Army, this notion that you deploy these monkeys who go kill pieces of your infrastructure in production. And the goal of that is that when you're building a service that operates 24/7 worldwide, you want to have this kind of testing that happens in production. You cannot test for all failure modes at testing time. And so they developed this kind of this army of monkeys that test various aspects of the system that just kill daemons or kill whole VMs or kill whole subnets. And the big one, the gorilla one, I think kills the whole availability zone and then gives you some results about how stuff works. It's all open source. You can use it in your own projects. VMware, oh wow, I'm running really late, so I'll go very quickly. VMware, Cloud Foundry, open source platform as a service. It's a distributed system. What's interested in there, to me, the most interesting aspect is Cloud Foundry Bosch, and it's open source. And Bosch is the system that, it's a distributed system itself that you use to deploy Cloud Foundry and update it. And that's the equivalent of the Fabric in Azure. The difference is that this one is open source, so you can go and study it and maybe take pieces of it if you're building your own cloud. One of the very interesting aspects in Bosch is this CPI, this notion of cloud provider interface, where to deploy Cloud Foundry, you can deploy it on vSphere, but you can also deploy it on Amazon Web Services and OpenStack. And they have this cloud provider interface that you need to provide an implementation on for various cloud APIs. I really do hope that they implement it for Azure now that I'm not there anymore. Last thing I wanted to mention, wow, I'm really running late, is Docker. You guys should take a look at that. There's been this discussion about this distinction between infrastructure as a service and platform as a service that's been made for many years. And to me, that distinction is starting to fade a little bit between infrastructure as a service, and then you're using things like Puppet and Chef to automate your own set of things that you want to install. Or you're using the Netflix open source tools to just deploy your own templates. Now there's a new aspect that sits between infrastructure and platform, which is Docker. And Docker could replace, it's an easy implementation of Linux containers to isolate different workloads. And the beauty of it is that it makes it super easy in development. So when you're developing, you can build a machine with Vagrant and then deploy your application to a Docker container, and it takes a minute to start as opposed to maybe 5 minutes for a VM or 30 seconds. So it starts much faster than VMs. At last, this is how I view the cloud market. I presented that to my colleagues recently. I use movie as an analogy. So VMware, they're like the guys in that 300 movie. They're dominating their area, but they're resisting. But Microsoft is very strongly going against them. I think you know how that movie finishes. Amazon, it's It's Pacific Rim, so it's the big monsters that come out of nowhere under the Pacific and invade the enterprise market. They are not tooled for that, and you all know how that movie ends as well. Google, I compare that as to Back to the Future. So I don't know if you remember Marty. He's coming from the 80s and he goes back to the 50s and start playing hard rock there. And you can look at the face of people when they from the 50s when they listen to that 80s music. They're dumbfounded. Well, that's how I felt when I was presenting Google Cloud Platform in the enterprise. So I don't consider them as very serious competitors today. And Microsoft are pretty strong in hybrid cloud today. I have a bunch of recommendations in there that comes from what we talked about in that talk. The unit of scale is changing. It's having a horizontal, scalable, uniform infrastructure is important. The notion of fabric is important. The fact that tests and production lines are blurring. DevOps and the pizza box team, the two pizza team. Open source really helps you get vendor independence and share the load for building cloud platforms, give you uniform tools. IaaS and PaaS are a continuum, and vertical clouds I think will be important as well as sovereign clouds. And among the big three, I think Microsoft is very well positioned for hybrid and especially for Java developers. So that's it. I have a bunch of links at the back of my presentation, and I'll publish it later today. Do we have time for any questions?
Yes, we do.
Awesome.
Out of microphones, and this one is on a cable, so please ask a question and Patrick will repeat it.
Yeah, I'll just repeat it.
Okay. Any questions?
Wow.
Interested? I do have a question, actually. So I'm not missing someone. No. A question on personal clouds. So in my case over there, I have lots of more hardware, bigger batteries, and a larger screen, and whatever. Whereas in my pocket, I have a small device, and it has a smaller battery, of course. Are you seeing something similar here, that I will be able to just stream the power of my stuff in my bag and use it in my hand?
Yeah. So the question is about personal clouds. And summarizing it, it's like we all have devices of various capacities, from desktop to laptops, and then we have these small devices. And how are they going to communicate together, and can they leverage the power of each other? And to me, that's a great question, and I think it goes to the fact that today we're in this devices and services world where all the devices we're using are interacting with single services in the cloud. So what you're describing is it's more a distributed model where you would have some smarts in all the devices, and then they could listen to each other and start to leverage what they have. I think and that's true for storage, it can be true for processing power. I'd say right now we're more in a centralized mode where everything gets centralized in centralized services. It's much easier to implement, and then you get the result in all the devices. And synchronization is key here. For example, I don't know if you looked at Dropbox synchronization API. So that's kind of what their business is. They synchronize all your devices with a single service online. Getting to leveraging distributed capabilities, I think we'll get there, but I don't see that happening right away, not next year. But I think it's an important theme for the future, for sure.
Mm-hmm. Okay. Yes.
Imagine that I have a team of 5 members, and I would like to run the team in cloud. So they will develop in cloud and deploy in cloud. So which of the solutions that was presented makes better for this particular case? If I would like to have less problem when on infrastructure.
Okay, so the question is, I have a team of five members. I want them to develop in cloud and deploy in cloud. which of the solution would be the best. So again, I don't want to mandate solutions and say this one is better than this one. It kind of depends on the requirements, what type of apps you're building and all that. All I can mention is a few potential solutions. In the Microsoft world, it would be Visual Studio Online. So it's online, it's in the browser, it supports Git, and then it supports Azure, and there are lots of ties there. So that's kind of the Microsoft solution to everything. No.
Ruby is not supported, at least explicitly, by any of those companies.
So now let's say you're in Ruby, you're in a different language. So there are lots of other cloud IDEs, for example. So I would use, you could use GitHub for hosting your code. Then you could use the Exo Cloud IDE, which works in Java, Ruby, I think it does JavaScript as well. Exo is the only one. They changed name recently, but it's called the Exo Cloud IDE. There's another one that's called Cloud9 that's pretty good. So you have a bunch of cloud IDEs who would work with any Git provider. So you choose a Git service and then you choose a cloud IDE. Then you need your, if you're in Ruby, you'll need a Travis service that runs online. So I don't know the list of the providers of people who provide Travis service, but you see where I'm going with this, which is from the Cloud IDE to the where you're going to log your bugs, whether it's Jira Online, you're going to have to assemble a bunch of services together that fit the type of apps that you're building.
Yeah, this is my point. So, are there any solution that provides everything out of the box? Because I definitely will need a build server, definitely collaboration tool, bug tracker, some help desk for my customers. So, but currently I need to assemble it myself.
Yeah, so that's a very good point. So the point is today you need to assemble your stack yourself. And that's definitely the case. So it depends which kind of stack you're using. I know that Microsoft is trying to integrate all that stuff as much as we can, but it depends which kind of workloads and which kind of languages you're using, because our offerings are not mature for everything in every area. So if you're developing in .NET, for sure we have the most mature stuff. I think for Java it's starting to get better. For Node, it's starting to get better as well. For Ruby, I don't think we're there yet, for example. So you would still need to complement it with other cloud services. But to me, that's the beauty of cloud services, where you're not forced into using a single provider for everything. You need to have integration with various services. Right now, integration can require some coding and automation to make everything work together. I expect that these kind of difficulties will be alleviated in the next few years as various players are playing together in order to integrate things into single services.
Okay, I think we're out of time. It's time for lunch, and
All right.
thank the speaker.
No, thanks
Thank
very
you.
much. Thanks.